Good morning, afternoon, evening, midnight, whatever time it is where you are. I'm coming at you live from Albuquerque, New Mexico. This is your science teacher, Mr. S. Welcome to the PowerPoint, everybody. Today I wanted to go over water availability and the water cycle. Obviously, we're from New Mexico. I'm sure you all know why water is so important. We know it here more than anywhere else, probably. And so let's get right into it. All right, so there are guided notes attached to this assignment for you to follow along with. It's not mandatory, but it will really help you just kind of learn the material and write it down. I know most of you probably can't print the notes, which it could be really nice for you if you could. But otherwise, you can just type it in on one half of the screen. So obviously, water is important. It's vital for all life. It has a lot to do with the climate because it absorbs a lot of heat. It sculpts the land. It removes and dilutes wastes and pollutants. And it moves continually through the hydrologic cycle. So that's what we're going to be talking about. Hydro, as you probably know, is water. Okay? So anytime you want to pause the video, please do rewind it. That's one of the great things about lecture videos. Okay, so here are two different spheres, right? So if we took all the water in the world and put it into a sphere, the big sphere would be all the water on the planet, including oceans, okay? And then the fresh liquid water in the ground, lakes, rivers, swamps, would be only 169.5 miles in diameter, the size of Kentucky. And freshwater lakes and rivers would be the sphere over Georgia. You can barely see it, that little one. And that one is pretty small, only 34.5 miles in diameter. So the point of this is there's not that much water. There is in the ocean, right? And we do have ways of converting that into clean water, or drinkable water, I should say, but it uses a lot of energy and it's very complex. This is all the water we have available, fresh water, to be used if you put it into a ball, which is pretty crazy to think about. It's very precious, right? So this is in your notes. Figure out a way to draw this, whether you can draw it on a piece of paper, take a picture and put it in your notes, or if you can figure out a way to annotate your notes in the document. It's kind of was made to be drawn on, but you can also just maybe make a note in there. So out of the total global water, oceans make up 96.5%. And then saline, remember, hopefully you know this word by now with the beans. There are salt lakes and also saline groundwater make up a little bit more. And then if we look at the amount, all the fresh water in the planet, most of it's in glaciers and ice caps, okay? And then only 30% of it is in groundwater and 1% surface water and other fresh water, okay? And then if we looked at all of the surface water and other fresh water, let's see, most of it's in ice and snow again. And then we have a good portion in lakes. And then you have soil, water in the soil, swamps, rivers, biological water, and water in the atmosphere. So very little. Most of it's frozen, actually. Only about 0.02% of the Earth's water supply is available to us as liquid fresh water. Okay? So take a second and read this comic. Pause the video if you want. It should be funny to you. And just think about that for a second. Okay? That's such a small amount of our water that we have on Earth is capable to be used to drink and use in our farm fields. You've learned that salt is really detrimental to farm fields, right? So this is a very precious resource. So small, such a small amount. Skipping that. Okay, so here is the water cycle, and I want you to understand one major concept in this. Okay, and that is the difference between transformation and transfer. They sound similar, but transformation is when water changes form completely. Okay, and transfer just means it moves from one place to the next. So transfer and movement would be infiltration, runoff, plant uptake, and transpiration when it goes through the plant leaves. That's transpiration. Seepage, precipitation, consumption, drinking. Okay, so anytime it's just moving from one place to another. Whereas transformation is when it becomes evaporation, right? When it goes from water to gas. So that's I want you to really remember these terms. Evaporation, sublimation, when it goes straight from a solid to a gas, so from like ice to gas. Freezing, condensation, when the gas condenses. That's what happens in clouds. Okay, you have condensation here, where the water condenses as a gas and gets thick enough to cause precipitation. Okay, that would be a transfer though. So condensation, fog, drip, those are all transformations. When it's going from water to gas, gas back to water, or also from ice to gas, or from water to ice. Anytime it changes form, right? We have ice, gas, and water. Okay, that would be transformation. And the climate change effects are due to climate change, changing the gases in the atmosphere over a long period of time, and the warming of the planet. We'll have precipitation increases and decreases in certain areas. So some places will have droughts and others floods. The sea levels rise, loss of ice habitat. So we see like in the North Pole and things, the ice is melting. And then freshwater sources like glaciers, and also the running out of groundwater. And then the other important human effects are pollution, chemicals, toxic metals. We talked about eutrophication. So I want you to remember that word. Write it down, please, if you can. EUTROPHICATION. And that's where excess nutrients, so nitrogen and phosphorus, right, from farm fields get into the water and cause algae blooms, which choke out the life. And then reservoirs. Remember we talked about reservoirs are big areas where the material is held. So we have lakes, rivers, snow, clouds, atmosphere, biological storage, and groundwater. And we're going to review all of these in the next slide. So hopefully you've filled out these charts, but we're going to go through it still so you can add on. So transfer is infiltration, runoff, plant uptake and transpiration, seepage, precipitation. So this is any time that the water is moving from one place to the next. So not in the picture is consumption or percolation. And infiltration is when water first enters the soil. Percolation is when water is circulating in the soil. Transformation is snowmelt, evaporation, sublimation, freezing, condensation, or fog drip. So remember, that's any time that it's going from liquid to gas, gas to liquid. Gas to liquid, it would be like fog drip, right? Or when it's water and it goes to gas, it's evaporation. Sublimation is ice to gas. Freezing, so all of those things. And then the climate change effects are precipitation increases and decreases, droughts and flooding, sea level rises, loss of ice habitat and freshwater sources, and groundwater depletion. So I want you to think about this a lot for your test and kind of understand how the water cycle can be changed by humans. We also do have pollution, the nutrients, so this is important because we learned it in the other nitrogen, phosphorus cycle, and thermal pollution. And where most of the water is held is ocean, lakes, rivers, snow, clouds, atmosphere, and groundwater. Okay, make sure you can pause the video to fill in the rest of the data. And because we're 12 minutes in, I highly suggest pausing and taking a break and going and getting some water, because this is about the time that students lose focus. Okay, so take a break, make sure your notes are finished, and then continue with the video. Okay, so this is the important water vocabulary. So make your best guesses for the matching before I show you the answers. So you can just put down the letters that, so you don't have to cross out the wrong answers. Yeah, so try to see if you understand all these vocabulary words in your notes. Okay, so pause the video, do that, and then I'll show you the answers later on. Okay, so groundwater, precipitation infiltrates. Remember, infiltrate means moves through the ground and is stored in soil and rock. Okay, so that's where the water gets stored, and then before it gets taken into the plants, infiltration, it's moving in and gets stored in an aquifer, right? Surface runoff is when water that does not sink into the ground or evaporate into the air runs off into bodies of water. So every time it rains a bunch, some of that water will go into the earth, right? And to a certain point until it's saturated or completely filled with water. Then the rest of the water will run off. It'll flow off the land. And that can move a lot of the earth, and it can cause flooding, right? Mudslides, you name it. And then a watershed is the land area that delivers runoff, sediment, and any dissolved substances to a stream. So this would be a watershed. It's all of the areas where the water flows to the one main area, right? And that's the watershed. Area of land that drains to a particular point. So ours is the Rio Grande, obviously, and I'm going to show you some maps of that. And here we have underground caverns and porous layers of sand, gravel, or bedrock through which groundwater flows. Okay? So groundwater will move through and go into these underground aquifers. This is really important that we do not take too much, right? Because there's a lot of water in there. And this is where we get a lot of our water, is in these deep aquifers that you have to drill a well for. Okay, and that's an aquifer. So underground caverns of porous layers of sand, gravel, or bedrock through which the groundwater moves. And your water table is the level below which the ground is saturated with water. So you have the earth here, right? And then if there's underground water, it's the certain level that it's at, right? So that's an important measurement, especially here in New Mexico. Okay. And so then we have two different types, confined and unconfined. So confined would be there's a permeable, meaning water can move through, water table. And confined means it's bounded above and below by less permeable beds of rock where the water is confined under pressure. So the important thing would be some aquifers are replenished by precipitation and others are not, right? So you could see this unconfined aquifer is getting all the water that's coming in. and a confined aquifer is not getting any extra water. So you could think about, just take a second and think about which one would be more dangerous to pull a lot of water from. Think about it. Okay, maybe the one that doesn't have all the water flooding in, right? The confined. Okay, and then we have artesian wells. So pressure from the confined aquifer pushes water up at a location without a pump. Okay, so this is how a lot of us get our wells or our water in New Mexico. So it just has to do with where the gravity is and where the water flows. The way that they drill the well, it allows a natural pressure to come up and bring us the well. But you don't need to worry about all of this vocabulary. Just get the main idea. All right, so this is just a brief mention of how watersheds work. We're going to have a much more thorough understanding of watersheds, but this is just a basic understanding, right? So there's an outline where all the water that lands here is going to go down into this watershed, right? And you have all this wetlands and all this area, and it's all flowing to the same area. So here's the Albuquerque watershed. So you have the mountains here, the Sandias, and all of this water, all of these little red lines are where the water flows down, right? So everything is kind of flooded to the Rio Grande Valley, or the basin here. So all of our water ends up there. There are maybe a few reservoirs, maybe one reservoir or so, where we keep a lot of it. And but this is generally where we would map our water sheds. Some people have a little bit different of a drawing. Like, for example, this might be one where all of this would be considered one watershed. You could break them up into different smaller watersheds, but overall it's going to look like this, right? This is basically our watershed. It's all focused on the Rio. And all of these little streams and ditches, they all go to the Rio Grande, as you all probably know. So that would be our watershed. And so here's the water cycle diagram. So we're just going to look at a few different ones and kind of look at some differences and similarities in them. So remember, the water infiltrates into the land, or it runs off, right? Here's snowmelt runoff. Some of it comes out as groundwater in a spring or a seepage. And then a lot of the groundwater storage comes out into the ocean or somewhere else. We have oceans or big bodies of water that everything is driven by the sun, okay? So the sun that heats up the water, it causes the water to become gas. That's evaporation. And then the water goes into the atmosphere and it condenses, or that's condensation here. And gets denser and denser, and once the water gets dense enough, precipitation or rainfall or snow, right? And then that goes into all the runoff and streams, and then you also have ice and snow in some areas, right? That runs off. We have that a lot, especially in northern New Mexico. In this one, you can see the sun is portrayed better, right? So this is what's driving the whole factor, the whole cycle. It's causing evaporation, which leads to condensation, and then precipitation. And then you have runoff, infiltration, percolation. So I want you to understand all of those terms, stream flow, and just understand how this cycle works. So as I'm going through these, you can go back and pause them and kind of read over them and understand them. This would be a good one. You could screenshot this one. In the Windows, you can just press print screen, but in other Chromebooks, I don't know how it goes. But anyways, sublevation, snow to vapor, deposition, storage in snow and ice, transpiration. The other ones didn't have this, so this is a big part too. Plants take in water through their roots, and then they transpire the water through their leaves. So they release the water into the air through their leaves, and that's what pulls the water into the plant as well. And we're just wrapping up here. So here's one more diagram. Just take a look at it, read through it, pause the video, make sure that you kind of understand this cycle, okay? And if you have any questions, just email me, okay? We can go through it. But just make sure you're really comfortable with all the different cycles. So this would be climate change, okay? So these are all the things that can happen due to climate change. Changes in the water temperature. So the water, because of human activity, there's increased sediment. So like earth in the water. The water temperature is rising, as we learned in the Coral movie. It's causing evaporation at a higher rate. There's more water used by plants when it's hot. Increase in rainfall from heavy precipitation events, so more flooding. Decreases in snowfall, and then increases in rainfall. Increased water usage because of drier climates. More droughts. So a lot of tricky things because of climate change for our water cycle. So look over the diagram, and I'm going to have a condensed list on the next slide. Okay, so when there's more or less precipitation in depending on where you are, there might be more fires, right? Or more flooding and hurricanes. Increased irrigation and uptake required, so less groundwater. So that's one of the big issues, is farmers pulling up the water from the aquifers and using them in farming. So if it becomes drier, then they're going to use that groundwater more. And then decrease in land and sea ice and sea level rise. So this could happen over 100 or 200 years even. And I'm interested to hear your perspectives on climate change as we go into the course. We're just getting started, but these are kind of the water cycle is one of the major things that's going to be affected. And here were the answers to those vocabulary questions that I introduced at the beginning. And some kittens in a bucket. So sometimes water's in a bucket, and sometimes kittens are in a bucket. So that's why this is relevant. All right. Try to finish up those notes and use them to study for Friday. I know this was a long slide, so hopefully you took a break halfway. And thank you for listening and taking notes. See you soon. Adios.